Hi guys, welcome to another Learn Electronics repair video. This package turned up today and I've got a good idea what's inside this. Came from AliExpress. Let's open it up and see what we have here. Yep, it's what I thought it was. Smart Digital Multimeter. KM601. Kaiweets Smart Digital Multimeter. So the reason I knew what was in here, I've been waiting for this for a little while, this package. So Kaiweets, who make these, emailed me a month or so ago and asked me if I would have a look at their multimeter from the point of view of repair. You know, is this a good multimeter for repair? And I said, yeah, sure. So they've sent me this multimeter. I will say I haven't paid for it. They have sent it to me. But they're not paying me to make a review. This is an honest opinion. In fact, the email they sent me said that I could freely express my opinion of this multimeter. So I accepted that. We have one multimeter arrived. And let's have a look to see what's in the box. It comes in a nice pack and it has an instruction manual. So let's just start with this. Actually, it's an English instruction manual. Yeah, in fact, it is an English instruction manual. The whole thing. So we seem to have a fairly decent instruction manual here. And this is the meter. Okay, so let's see. Well, it fits in quite snugly, I will say. That's a snug fit. Oh, that looks quite nice. We have 8 batteries. I don't know if it takes all 8 or if we have a spare set. We have a thermocouple probe. So this is also a temperature meter and it includes the probe, so we can try that. And we have some meter probes, so let's have a look at these as well. Let's see what we have. These are fairly standard type probes. These are not the sharp ones which I like to use, I will say that. I use these. I find for repair work they're much better to use. They're much sharper. I don't know. They don't screw off or on. They don't appear to be interchangeable tips, and anyway, that's what they came with. So yeah, I mean, I prefer the sharp ones. I will say that, but that's not a problem. I mean, we can plug in whatever we like into this. Looks like it has a little plastic protecting sleeve thing on the front of it, which probably just peels off. Looks that way. It seems to have like a little bit there where it should just lift off. Yeah, it has like a little plastic tab, so you can take that off. And here we have the multimeter. An interesting thing I noticed is that the connections are underneath it. If it was standing up that way, yeah. And obviously it's lying down, so effectively the connections are not here. So we can put some batteries in. Let's have a look, see what it takes in the way of batteries. Notice I haven't read the instruction manual, by the way, so that's you know, that's me trying to prove if this is very intuitive to use. Oh, it has a torch built in. I remember seeing that. There's a torch built into this, which might be quite handy if you were using it on site. Let's see what we've got. Yeah, so quite a tight fit, but that's probably a good thing. There's an on-off switch at the top of it. I'm guessing we need to take this cover off to fit some batteries. Okay, yeah, we do. Remove test leads before changing batteries. Well, let's see if there's any. I doubt there's any in here. No, it doesn't have anything in here. So the first thing we need to do here is to put some batteries in this. Yeah, it looks like there's just a few screws, so I'll open it up and let's see how many batteries it takes. The cover came off quite easily, 3 screws. So it actually takes 3 batteries. So for whatever reason, they send us a spare set of batteries. I don't know don't suppose that's because the batteries, you know, drain fast to you. If not, it's quite generous that we get 6 batteries when we only need 3. So yeah, let's get the batteries in here. Okay, I'll put the screws back in. Oh, it made a bleep, and it's on. Oh, what? Yeah. Oh, that looks nice. Okay, let's yep, switch it off, and then let's put the back on, and then let's try it. Here we have it all back together. So there's a torch button on the side. Interesting, the torch doesn't seem to work. Maybe you need to switch it on first. Okay, maybe you have to switch it on before you can use the torch. Oh yeah, there you go. Oh, that's interesting. I mean, I would have thought maybe the torch would come on without that, but never mind. It's not really a problem. You switch it on when you have a torch, which I suppose can be quite useful because the torch, you know, in fact, is like a mobile phone. There's a torch behind. Yeah, and it gives us quite a decent amount of light actually. So if you're working on site on something, that's quite handy. What's this display doing? So I could read instructions to this, but let's have a go. Well, the thing is kind of like flicking between volts, ohms, and sound by itself. It says it's auto ranging, which has a range, so I'm guessing it says manual ranging. Let's just press the button. All right, here we go. It's giving me the temperature. Interestingly, without the temperature probe fitted, I think it's just the ambient temperature, and that's probably actually about right. Yeah, there's one of my temperature meters, but I'm not sure exactly how accurate these temperature meters are, to be quite honest. They're not calibrated, but the reading is similar. And that's about normal for my workshop. Ambient temperature. What else do we have? So, this is resistance mode. Oh, this is interesting. You see these are flashing on and off here. When I selected the range, did you see, look? Yeah, that's showing you which sockets to put the cables in. So for instance, we're on diode test mode, it's saying there capacitance. So I'm assuming if we choose amps or milliamps, oh yeah, it just steps through them. Yeah, look, it's flashing common in milliamps, and it's flashing common in amps. That's nice actually. I like that because it's showing you where you need to insert the lead. It's now saying leads. That means if I put some leads in, it will know that they're in there. One there. Let's have a look. Yeah. Oh, I like that. That I do like. That I do like. I mean, it's quite a common beginner's mistake to connect the leads incorrectly to a meter when you're using it in current mode. Now, auto function doesn't seem to do anything now. Like you can't change it. Is that because the leads are in there and it won't let you change it? Let's try it. Put it to milliamps. Oh yeah, look, yeah. So I connect the cable to the milliamps and it changes automatically to milliamps. And if I connect the cable to the resistance, voltage, and etc. Oh yeah, I see. Yeah, it was flashing the red light at the top as well. So this is without reading the manual, guys. This is just me. But if something's intuitive to use, that's a good sign. Yeah, look. Showing you the lead's wrong and it's showing you where they should go. Okay, that I like. I've noticed a very nicely thought out feature with this as well. So as I was showing you, we can go on the ranges, okay, to milliamps, and it gives us a red light, it says lead, and it shows us where to put the leads. So we can now put the leads in the correct place for milliamps. If we now try and select amps, we cannot select amps. You cannot select the amps range because the lead is in the wrong place. So we go to amps, and now it's gone to amps on its own, yeah? So this means that you can't accidentally select amps and use it on milliamps range and blow the internal fuse. What I really like about this is if I disconnect the lead, yeah, it says lead, if I plug it back into the milliamps, look, it automatically changes the range back to milliamps. That is very, very well thought out feature, in my opinion. I've seen a few other people reviewing these meters, and what they've been doing is effectively, comparing the reading. So they take like a reference resistance device or a reference voltage device, and they're seeing how accurate is this meter to measure current, resistance, and volts. But in my opinion, from the point of view of repair, that isn't the main thing. There are a number of factors that I look for on a multimeter, and I'm using it for repair, and this is a repair channel. So the main ones I look for is, one, does it have a stable reading when you're reading millivolts or volts? Is it stable? You don't want it wandering around, yeah? Number two, resistance and continuity mode and diode test mode. It's nice to have a bleeper in both resistance mode and in diode test mode, so we'll try that. And also, it's how fast does it react? If you're probing around the circuit board looking for continuity, you need to react very much instantly when you touch the contacts together. So speed of reaction, that's important to me for a test meter. And the third one, which is quite handy, is capacitance range, and how wide a range will it give you and how quick is it to read capacitors. And the other one is the hertz range, frequency. How high a frequency can it read? Can you use this to measure, for instance, oscillators on a PCB? Can you use it for measuring things like buck regulators, where you just want to see, is it oscillating and what frequency, or at least roughly what frequency. So let's have a play with it. So first of all, let's go to ohms range. We're in ohms range now. Let's see if this will. Yeah, it's not instant on ohms range. It takes a little, not long, it just takes a little while to just read. But I'm more interested in continuity mode. Let's go. This is ohms range. Right, it's ohms range. And it's giving a bleep. Well, you see when I'm just touching them like this, it doesn't respond instantly. I'll compare that with my fluke meter, just out of interest, and also with the Aneng meter. So on the fluke, if I go to ohms range, continuity, not diode mode, I put the bleeper on. That's diode mode. It's about the same. Let me go to ohms range. It's not exactly instant, so let's just try this one again. Okay, maybe fractionally slower, but there isn't a great deal in it, I'll have to say. So again. No, I'd have to say that's pretty good. That is pretty good. Maybe not quite as fast as a fluke, but this is a very expensive multimeter. I will just show you on a real life example why this feature is important. So this is my fluke meter, and I can just touch the leads together. I'm in the continuity mode, and you'll see that, or rather you'll hear that it bleeps even quicker than the display can react. So it takes a little bit longer to get a reading, but I get the audible signal. So for instance, as a good example, here's an inductor choke, possibly part of a buck regulator, and you may want to know where that voltage rail actually goes to. So for instance, does it go to this chip here? And to do that, really, you're just going to take your meter probe and quickly go across the pins. So you can straight away, I can see it goes to there. Yeah, let's try up here. Yeah, so you can see I've got contacts, or rather you can hear I've got contacts. Yeah, nothing on that side. So when you're fault finding, you often don't know where something's going to, but you need to find out. And this meter is definitely telling us that it goes to this chip, and then we can actually zoom in on the actual pins, we get a bleep and find out where it goes. So let's try this now on the Kaiweets meter, and let's see if it works as well as the Fluke. Once again, I have a meter in continuity mode, and we can just touch the probes together, and you can see the little green light flashing at the top of the meter before it gives the display. So this is looking quite promising. So again, we'll connect to our buck regulator coil. Let's see if it'll find it. So we know there was nothing across this top edge. Let's just go quickly up this side. Yeah, it may be fractionally slower than the Fluke, but it's certainly doing the job. It's certainly telling us whether we have a contact while I'm just brushing across all the pins. Yeah. Yeah, that's good enough, you know. That's good enough for fault finding. And the same thing happens, you get the bleep and the little green light flashing before you get to display. So yeah, for that use, I think that's fine. What I do quite like is the little light at the top. So if you're in a noisy environment, or for that matter, if you're hard of hearing, you can see a visual indication. That I do like. Next one then. Let's have a look at diode mode. So diode test mode, again it might well bleep. I know this doesn't bleep in test mode. Oh, it does. Right. This is quite nice. So it gives a little blip, whereas in the bleeper mode, we'll just go back to it. Gives you a continuous bleep. Yeah. In diode mode, gives you a blip, and I'm assuming that if we take a semiconductor device like a diode and we connect it to here, then we will just get one blip, which is quite nice, which shows you the difference audibly between a short and a semiconductor. Let me just try that. Yes, I have a diode now, and we can just connect it, and we get one bleep, and it shows the reading. As opposed to in the continuity mode, it effectively gives you continuous tone. That's quite a nice feature. You find that on quite a few meters, but I like that. So when you're probing around on a board, one blip will tell you on the semiconductor junction, and the continuous will tell you effectively on the short. That I like. That's quite handy. Let's have a look at the capacitance range. So I'm interested to see what size capacitors this will read up to. I'm sure I could check in the manual, which I will just do, and then we'll try it and we'll see. With capacitance measurement on a multimeter, normally it takes a bit of time. This is why I have a separate capacitance meter. But they will read though. I mean, that's 250 nanofarads, and the capacitor is marked at 220, so that's close. Basically, the higher the capacitance, the longer it generally takes these meters. But that's not just this one. The other meters I have, multimeters, also take some time. So to measure a large capacitor like this one, it's taking what, 10 seconds. Okay, so that's actually like 3.368 millifarads, which is like 3,370 microfarads, and that's actually 3,300. So that's reading well enough for the point of view of repair. Let's have a look at the millivolt scale. So millivolts. This will read down to 0.01 of a millivolt. I'll just short them together. It should just go to 0. Yeah, 0.01. Compares with the Neng that I use, particularly on millivolts, because this will actually read to 0.001, which is very nice, especially if you're doing short circuit tracing where you are injecting current and you are using this to find the point of the lowest voltage. And also with the short circuit finder, the amazing $1 short circuit finder I built. This has about 10 times the resolution of this. But having said that, the Fluke on millivolts only reads to 0.1. So in actual fact, This has 10 times the accuracy of this one. Hertz range. Now, this is something I'm going to test in the mains actually on a device to see what frequency this will actually measure. But we can have a quick look in the manual and see what the range it says it can handle. If we can just find that, should be quite easy to find. Frequency. Yeah, this reads according to this up to 10 megahertz. That again is kind of in the middle. This one is only about, I think it's 20 kilohertz, and this will read up into the hundreds of megahertz. But for the most part, the things that we want to check frequencies on for a repair point of view, which is a pulse width modulator running, is it generating the frequency? Most of those, even on power supplies, VRMs, are running in the hundreds of kilohertz range. So 10 megahertz is more than enough for measuring that, and we can just test that. Resolution of resistance is 0.01 of an ohm. Again, you can just look at that compared with the Aneng. Yeah, same, 0.01, so they're the same. The Fluke's actually worse, it's only 0.1. So resistance wise, same as that meter. And another feature this has is duty cycle, which I don't believe either of the other 2 meters I have actually will measure. The duty cycle. Oh yeah, one thing I think this will do, it'll actually show us the duty cycle as a percentage and the frequency at the same time. That is rather nice actually, and we can have a little play with that. You can have the temperature in Fahrenheit or centigrade selected it. Not quite sure how you switch, but again I haven't read the instructions. Live tester, I haven't tried this, but I believe you can actually use this to test if there's current flowing in a cable, if the cable is live. Let's just try it again. I've not read the instruction book. But what's this do? Will it actually tell you if the voltage? Oh yeah, hot. Oh, that's nice. So this will tell you whether a cable is live, even if there's no load on it. It's not, it's not connected to anything. Hot, yeah, that I like. That's nice. Okay, I think we've had enough of a play around with the actual meter without reading any instructions. Let's just try making a few measurements on the circuit board. This is the motherboard I use for testing graphics cards mainly. So we can just use this just for a few checks we can make. So first of all, we'll go to volts range. One thing I have noticed with this, but it's not really a problem, is that when you first switch on, you have to select a range, whereas normally on your other meter, well I suppose you do, but you just turn the knob to select a range. But that's not a problem, I don't think. So we can go on to ground and we can just check some of the voltage supplies. Now you'll notice that I can't get these meter probes down into the connector here. Oh, I can, but not so easily. But it's reading 3.36. I mean, this is why I would always use a sharp meter probe. This is not really a criticism of this meter, because to be honest, I would always do that anyway. No matter what I buy, even the Fluke, I end up using the meter probes that I like. This is a personal preference. So like anything else you buy, you have to put your own meter probes on it really. So yeah, 3.36, fine. 12. It's quite responsive actually. 5. Let's go to the green one. It should be 3.3, or no, it should be low actually in red here. Let's have a look, just check a couple other things. CMOS battery, 298. So yeah, there may be just a slight delay, but it's certainly good enough for testing, that's for sure. Let's have a look. 4.95. Another voltage regulator here. 2.14. What it definitely does do is gives a very stable reading, whereas this one tends to wander around a little bit. It does give a very stable reading, and that I do like. Let's try now the frequency range. So I'm going to just press auto. Yeah, this one. Millivolts hertz. Right. So let's have a look at the buck regulator. See if we can see. Obviously, they are running because the board's working. Well, straight away it's picking up 50 hertz, and that's like the main hum, if you like. So if I go on to one of the VRMs, the CPU VRM, vCore, we can just make a contact on it, and let's have a look to see if we get a reading. Yeah, 293.8 kilohertz, and the duty cycle is 15.2%, which probably means it's throttling back. It's running quite low. This could be very handy, you know, for testing VRMs on graphics cards and such like, where they are effectively crashing under load, or when they load the drivers. Maybe give you some idea by measuring the duty cycle of how hard the VRM is running. I think that's quite a nice feature. It does have it on the Aneng, but you can only read them separately, so you have to choose hertz and then either hit select to choose frequency or duty cycle. This will show you them both together, and that I rather like, actually. We can go and find another one, I think. Okay, so this is now the memory VRM. We can get 298.6 kilohertz and 31.7% duty cycle. Yeah, I like that feature. That's quite nice, and it kind of holds for a little while for you. It does have a minimum and maximum, which you can effectively tell it to kind of like hold on the highest or the lowest voltage it reads, which is quite nice if you've got something where a voltage coming and going quite quickly. That's quite handy for repair. So first thoughts on this, and I'll keep the video fairly short, as I rather like it. The Aneng gives me an extra decimal point of accuracy on millivolts, which is quite nice for short circuit finding. But this one's better than the Fluke in that respect. This has some features I very much like, and I think you probably will as well, which is the flashing the connections down here when you effectively put the meter probes in the wrong position for the range, current, resistance, whatever the range is. I like the way it flashes this when you do a resistance check over continuity, especially good if your hearing isn't very good or if you're in a loud environment. I particularly like that. The torch is okay. I mean, I don't do much on-site work, so it's this side. Yeah, I don't do much on-site work, so for me it's a bit of a gimmick, but for some people I'm sure it's rather useful. There's another button here, I'm not quite sure what it does. Do you know, I'm going to have to read up and see what this button does. One moment. It puts like a little power symbol. Oh, it says APO, I bet it's auto power off. Oh, that's nice if it is. Just one moment. Yes, that's exactly what it is. So when the auto power off is on, this little symbol appears and it'll switch off after 15 minutes. It bleeps, I think it's 1 minute before it's going to shut down. Or you can switch that facility off, and I think that's rather nice actually. I rather like that. I thought when I first saw the design of this that I would be quite concerned that the probes plug in at the bottom, so it doesn't have like a little, you know, the bracket on the back you find, like the little wedge that allows you to stand the meter up. But although it doesn't come out so well on the camera because of the reflection, this actually has a very wide angle of view, so I can lean back, so I'm looking at a very shallow angle and still get a very, very good, even almost flat like so. I'm looking down the edge, I can see that display perfectly, and that I do like. It's not quite so much in the upwards direction, but that doesn't really matter because you're sitting at this end. So from this, we can directly down to the reading light back here. That display is excellent. That is very good. And for the YouTube channel, okay, this applies to me, but this is really nice. And I think a lot of you guys will agree you can see this much clearer than you can my other meter. I want to show you another feature of this multimeter as well, which I've not seen before on any other one. and that's this auto ranging mode. So you can see it's flicking between voltage, ohms and bleeper. And this is voltage AC or DC. So how this actually works is, when you connect your probes to the circuit, depending on what it finds there, if it's an AC voltage, a DC voltage, or no voltage at all but a continuity, it will select the range automatically. So it will give you voltage AC, voltage DC, ohms, continuity. So we'll just go to our little circuit board again. I can just show you how this actually works and how this might be useful if you're doing repair. So let's in fact zoom down on it so you can see clearly what I'm doing here. So we're in auto range. If we go to ground and we just measure some resistances on here, so the moment it's switched off, that the power's actually off. So for instance, that's telling me that's ground, yeah? 0 ohms. This is a voltage rail and it's showing me the resistance. 588 ohms, 590 ohms. So that's working quite well. It's actually showing me either a resistance or a connection to ground. Now let's put the power supply on and let's start the board up so it's running now. Now let's try it. So we can, for instance, go, there's a voltage regulator here. So without touching anything, it automatically knows we're in voltage range and it measures 3.356. So it's actually measuring voltage. Okay, 0.95. Now where this is quite handy is if I want to measure a voltage on a capacitor, for example, 1.06. Well, what happens if I go to the end of the capacitor which is actually connected to ground? So I just slipped. Let me go again. Right. So it's now telling me that there's a short here to ground, even though it's powered up. So it's telling me difference between 0 volts, but there's no short to ground, or 0 volts and there is a short to ground. And I find that rather handy. It's a feature I've not come across before on a multimeter, but I can see being very useful. So that's one I wanted to show you, and I did actually have to just check the instruction manual to figure that out because it to me was such an unusual feature. The feature where this works in this auto range and effectively will read AC or DC voltage, and by the way, when it reads AC voltage it shows you the frequency here rather than the ambient temperature. It's quite nice. That could be very useful for repair work. We'll have to test this a bit more on some real repairs. I'm wondering if you have a situation, for instance, where you have current sensor resistors connected from a source of a MOSFET to ground. Maybe it will just read the shorters rather than reading the voltage across the low resistance. But we'd have to test that before we can say. So the jury is out on that one. But at first sight, I think that's really a nice feature. I think it'd be very useful when we test it on the board, that we can see the difference between having a voltage rail that just doesn't have any supply on it and a voltage rail that has a short on it. So guys, you can see I'm really highly impressed with this KM601 multimeter, and I'd like to say thank you to Kaiweets for allowing me to review this meter honestly from the point of view of repair. I mean, this is a repair channel. No, this is a repair community these days, and that is a great opportunity to look at this. Is it the perfect multimeter for repair? Well, I don't think it actually exists. This is very, very good, and there's some features, the auto ranging feature which we were looking at, and the fact that it instructs you how to insert the meters when you're measuring milliamps, amps or voltage and other readings is excellent. I mean, it's not idiot proof, but it's fairly foolproof, and that's good. However, I did say I would give a very honest opinion, and I'll just mention a few things that I think would improve this. Most of them are probably just firmware changes. So this is for Kaiweets. This is for you guys, your R&D, maybe to see this from the point of view if you want to make the perfect multimeter for your electronics repair. Okay, so here we go. I'm going to do this by why would I pick up any of my other test meters? And I'll show you a few cases where I would, and this is involved. So on this one, we have the diode test mode. We can select diode test, and when I test the diode forward bias, it bleeps. So you can see we get a bleep and we get a voltage readout. Okay, obviously reverse bias gives nothing. That's good. What happens if we short the wires? Well, we get a bleep and it says 0. So there's a difference between a diode, a voltage drop on the junction, and a short. And that's okay, that's good, that works. But let me show you what the fluke meter does and why I would always use this when I'm probing around the circuit board in diode test mode. So we'll put this into diode test mode. Okay, take the meter probes. We'll take the same diode, forward bias, and it bleeps and gives a voltage reading. Now what happens when we short the leads? Continual bleep. So I don't need to look to see if that's saying 0 or if it's showing me a voltage drop while I'm probing around the board. I know straight away it's a short. That, I think, is just a firmware change on this, and that would be a really nice addition from the point of view of a repair. On a very similar topic, we have the continuity mode. This will give you a green light and a bleep on the short circuit. If we put this on the diodes, I'm just going to try this, we don't get one blip like we do on the fluke. And that's a feature I use a lot when I'm diagnosing circuit boards, and I'm sure I'm not the only one. If we take a resistor, this is a 47 ohm resistor, we still get the green light and the bleep, and it reads 46.6 is reading the resistor. The threshold is 50, so if we go to a 56 ohm resistor, it reads it, we don't get the light and the bleep. That's great, that's fine, and a lot of multimeters work in the same way. But you know what, guys? This has a second display here. Wouldn't it be a really cool feature if we could use that to set the threshold at which it would make the bleep? Yeah? And wouldn't it also be great if we could go to voltage range and again set a threshold over volts or under volts so that the meter will make an audible warning if that occurs? That'd be nice. And again, I think that's probably firmware just taking advantage of the secondary display. That's something I'd really like to see. These are not criticisms, by the way. I mean, I don't know of any meter that has all these features. Okay, I do like the way the fluke handles the diode test and the continuity. But another thing, and again, I've not seen this on any other meter, but this would be really nice. I have this meter. This is a milliohm meter. It uses Kelvin probes. So yeah, you have two wire probes, and it will read down to 20 milliohms. And this is really nice for finding short circuits. It will trace, even if you have a bank of surface mounted capacitors right next to each other, it will tell you which one's short. And that's a nice device, but having made a review of this one, I then went to build this little device. So this is using the Aneng meter, but you can use any multimeter, it would work with this one. And this basically uses a 4.5 volt external supply. We actually don't use the ohms range, we use the millivolt range, which gives me 3 decimal points. And this will actually read down to 1 microvolt. And with a little bit of calculations of Ohm's law, this also has a resolution of 20 milliohms. So that's a very nice thing to have. And we could use this method on here as well, albeit this only goes to 1 decimal point less. So this would be down to 200 microohms, not 20 microohms. Again, that could be firmware. We have the digits to display it. But wouldn't it be really, really nice, because of the clever way this switches the things, to be able to attach a Kelvin probe to this and use this to read down to 20 microohms as well? I'm sure that would be a hardware difference, another meter, but if that was integrated into this, this is now becoming the perfect meter for electronics repair. I have two other meters I use during my repair videos, so let's look at the reasons why I would need to pick those meters up rather than this one. One of them is probably a matter of convenience, and that's with the capacitance range. So this, we've tried measuring the capacitor earlier. So this is a 1000 microfarad capacitor, and if we just connect the meter probes to it, give it a couple of seconds, there we go. Nanofarads, just thinking about it. And it's 1000 microfarads or 1 millifarad, and that works as well as any other multimeter I've ever tried. They all work like that. The larger the capacitance, the longer it takes to read it. That's why I have this device. This is a capacitance meter. It's just a capacitance meter. This is manual ranging, which might be part of the reason it's faster, and maybe if it was auto ranging it would be a bit slower. However, we can take the same capacitor and we can just connect our meter probes, which we're not, and straight away, there's the reading. I've looked at the output of this on my oscilloscope. It seems to sound like a cycle of a sine wave followed by a square wave out through the probes. So I'm not sure how difficult that would be to add that function to a multimeter, but if that can be done, this ultimate perfect repair multimeter is getting close. So the last reason I would use another meter is that I have this one. This is my ESR meter. Now, if you've watched my videos, you've seen me use this in different ways. Yes, it reads ESR of capacitors, and it's great for finding faulty electrolytic capacitors, and that is a huge aid to repair. In fact, there's probably some repair jobs you would not complete or would take a long time if you didn't have this little machine. Okay, but I also use this to measure inductors down to into the micro henries range. It doesn't tell me the inductance, it gives me the resistance, the ESR, but using the reactance formula, which is very simple, I can just do a simple calculation and I know the value of very small inductors like the ones we find in buck regulators and similar. So that functionality, and this was like €45, and by the way, this meter is about the same price if you want to know the price of this meter, about €45 thereabouts, give or take. I've never seen it before, but to have a multimeter with built-in ESR of this type would be really, really useful, and I'll probably never have to pick this up again. In fact, dual display, ESR and capacitance, now that's something special. Yeah, that's another, if you like, a bit of a fantasy, but what I'd like to see in absolutely the perfect test meter. The last reason I can think of, which is why I would ever pick this one up if I have this one, which I do have this one, is that this will measure frequency well into the hundreds of megahertz, 150, maybe up to about 200 megahertz, which for the sort of repairs I do isn't really an issue. 10 megahertz is plenty, but for RF circuit repair I can see that there is a use for that, so that's another case where I may have to pick this test meter up. So to sum up, guys, this in my opinion is an excellent multimeter. If you're in the market for a multimeter, I think you can do a lot worse than buying one of these. There are cheaper multimeters that are good multimeters, but this has some really nice features which I believe are worth the price point. So if you're looking for a multimeter, I can absolutely recommend this. To Kaiweets, from the point of view of a repair technician, I made my thoughts, some of them are fantasies, because I don't know any other device that has all that functionality. But I think one day somebody will build that, and when they do, okay, a little bit more expensive than this, but when they do, I think that would be a killer multimeter for electronics repair. I'm really, really pleased to have this, and by the way, Kaiweets, thank you very much for the opportunity. You'll see me using this on my forthcoming videos. The display is very nice. I think it'll help in that way. So you're going to get to know this multimeter, and you're going to get to see how it performs over a number of live repairs. Okay guys, hope you enjoyed that. There's some links on this video if you're interested in buying one of these. at the normal price. I will hold my hand up and say if you buy from my links, I will get a little bit of commission. So you're helping me and supporting the channel. Ciao for now, guys. See you soon.